Hello, everyone. My name is Kelly Hall. I'm a marketing coordinator for ALS North America. I want to thank you all for joining us today for our Webinar Wednesday series. Our presenter today is Josh McKinney. Josh has 16 years of experience in the environmental testing industry. He has worked in several positions within the laboratory, including analyst, organic manager, and project manager. Now, Josh works in sales and business development for ALS Environmental at our Cincinnati laboratory. His commitment to client service, combined with his technical expertise and experience, make him a valued partner for our ALS clients. Today, Josh will be discussing TO15 vapor intrusion sampling. During this presentation, feel free to use your chat box, ask a question, or raise your hand features to ask any questions. Also, Josh, thank you so much for taking your time to deliver this presentation today. I will go ahead and turn it over to you.
Hi, good afternoon, everyone. This is Josh McKinney. Thanks again for joining us. A little background on this particular presentation. The title is Sampling Techniques, Analytical Considerations, and Best Practices when Communicating with the Laboratory. When I started with ALS in 2014, I previously did not have any experience with vapor intrusion sampling and testing in my laboratory career, and since then I've learned a lot. What became very apparent to me as I came along here with ALS is there are a lot of variations among laboratories about what type of equipment that they supply, and reporting limits, and different sorts of, I guess, accessories to summa canister sampling as well. So I really put this presentation together as sort of a guideline for communicating with the laboratory on your summa canister orders for, to best have success on your project. So we'll get started here. So an overview of this presentation is we'll go through a review of the canister sampling media. We'll talk a little bit about canister certification batch versus individual certifications. We'll talk about canister segregation at the laboratory, a little bit about SIM mode versus scan mode when we're analyzing the air samples at the lab. Overview of ordering sample supplies from the lab, and then very briefly at the end we'll go through a summary of passive air sampling collections. So a review of the canister sampling media here. You see we have some picture of some summa cans here. And what does summa refer to in the term summa canister? It's a stainless steel electropolishing process which electrochemically brings nickel and chromium to the surface of the steel. And this makes it smooth, mirror-like, and chemically inert. Another typical term for summa cans is to have a silanite-coated surface. You may have heard that out there, and that provides an increased level of inertness for part per trillion, or really ultra-low level analysis. So summa canisters, different sizes and types, here at the laboratory. We have a 6-liter size summa canister. That's traditionally used mainly for ambient and indoor air sampling. This is the 6-liter can here. The 1-liter size summa canister over here is used mainly for soil vapor, sub-slab, SVE system monitoring, and other applications. By default, when you put in your orders, at the laboratory, we try to provide 6-liter or 1-liter based on whether it's indoor or ambient air, soil vapor, or sub-slab. But sometimes supplies are short, and we may have to utilize 6-liter cans for soil vapor testing. That's pretty common, so you may run into that out there when dealing with your laboratory. These down here, I'm not sure if how familiar the group is with these, but these are bottle vacs, and these are like a 1 liter, amber glass bottle, similar, very exactly like you would use for sampling SVOC water. And these are used for samples with known high concentrations. So they would be a good option for testing a soil vapor extraction system, something like that, where you're expecting high VOCs. And that helps the lab out, so we don't have to do a really rigorous cleaning process to, clean out the summa cans with percent level VOCs in them. There may be reporting limit differences between these sizes, something to note. Flow controllers and sampling duration. So the flow controller, or maybe called a critical orifice assembly, is a device calibrated by the laboratory. And these have micron filters to keep particulate matter out of the canister valve. Does the micron filter keep out water as well, Mark? No. So if you suspect moisture, there are different filters that can filter out moisture as well. The laboratory will calibrate these flow controllers such that a small amount of vacuum remains after sampling. So again, the flow controllers are calibrated by the lab according to your requested sampling duration. So if you want to sample for 8 hours or 24 hours or 1 hour, these are calibrated by the laboratory. Pressure gauges. Flow controllers are fitted with analog gauges, which are not precision instruments. These should be used as a general indicator that the canister is sampling property. This is an analog gauge, and most of your flow controllers that come with your summa can and flow controller orders, they're fitted with the analog gauge. But again, those are not precision instruments. The laboratory checks for pressure with a digital NIST traceable annually calibrated precision gauge when they receive the can back at the lab. And here's a picture of a digital gauge. The client, you can purchase these on your own for use in the field if you wish. Ferrules, fittings, and tubings. So a 1/4-inch Teflon tubing and swage lock ferrules and fittings are used in connection from your sampling port to the summa or flow controller. The lab uses a 3/8-inch silicone sleeve attachment from the sampler tubing to the sampling port. So here you see our Teflon tubing with the ferrule and fitting, and here is the silicone sleeve that is going from the canister tubing down to the sampling port. In this instance, the sampling port is a vapor pen. The laboratory, we can also supply a swage lock fitting to go to your sampling port if you wish, but we need to know, what size that is and what configuration you need. So the laboratories do not provide the fittings and tubings upon request, or they do not provide them by default. So you need to request that specifically when you're ordering your cans and flow controllers. So canister certification. Canisters are cleaned in batches and reused. The canister cleaning process uses heat and hot air and nitrogen rinse cycles. And what you see a picture of here is a batch of canisters on a cleaning manifold. And these are all being cleaned together in a batch. There's either batch or individually certified canisters as clean. So batch certified means that in this grouping of canisters here, for example, we would pull off one can and check it on the instrument. And if that canister shows that it's clean, in other words, no detect for VOCs, you would assume that all the canisters in this batch are also clean. Individually certified means that we individually pull off each can and analyze them on the instrument to make sure that each individual can is clean. That process takes a little bit longer, and it's more expensive to get individually certified clean equipment.
Hey Josh, this is Kelly. I have a quick question came in from Michael. He asks, does ALS supply vapor pins?
We do not. They would need to buy those direct from the vendor. And that's Cox Colvin, in case I'm sure a lot of people out there may know. They're located here in Columbus.
Thank you.
Canister segregation. So all canisters and all related equipment may be, well, they not maybe, they are segregated in the laboratory, low level versus high level. If you're requesting SIM or ultra low level analysis, part per trillion reporting limits, we need to make sure that we are using canisters that are low level and that have not had previous high levels of VOCs in them. So those cans are segregated within the laboratory to assure that we have a high quality of data for ultra low level part per trillion work. Soil gas concentrations can span several orders of magnitude. We're usually dealing with high concentrations of TCE, PCEs, and very small amounts of carryover from these can yield suspect data. There's a note here saying that you can use Tedlar bags. I think we would prefer that you use the bottle vacs. If you suspect that you have high concentrations of VOCs. It helps the laboratory if you can provide the lab with your PID readings, or just give a heads up on the chain of custody or paperwork that you're issuing with the samples to the lab that, hey, these may be suspected high in concentration. SIM versus scan. Scan mode, and these are modes that is set on the instrumentation, the analytical instrumentation that is analyzing the air samples. Scan mode on the instrument yield, you can look for low part per billion levels, and that's kind of like that's the default mode, unless you unless you request low-level SIM mode. We would always default to scan mode, which is going to give you part per billion reporting limits. This allows you to pretty much look for the entire range, of VOCs, and also allows for total ion chromatograms, library searches, they're sometimes called. So selective ion monitoring, or SIM mode, the lab can achieve part per trillion levels with this mode. You look for specific compounds. It's typically a short list. This is well suited for PAHs and polychlorinated VOCs. It's not well suited for some hydrocarbons because you can get a potential false positive from those. SIM mode does require the silanite-coated canister treatment. For SIM, it's important to both have the canister and flow controller individually certified as well. So coordinating with the laboratory on summa orders, this is a slide that gives you all the items for consideration when requesting your sampling supplies from the laboratory. And I always say, if you take away anything from this presentation, this is the most important slide. because it has all of the information that the laboratory needs to know from the client. So are your samples subslab, soil gas, indoor air, or ambient air? What size of canisters do you need? 6 liter, 1 liter, Tedlar bag, bottle vac? What sampling durations are you after? What kind of canister certification do you need, batch or individual? Is there any regulatory program requirements, special certifications needed, and special RLs, reporting limits? Are you looking for ultra low, part per trillion reporting limits? What tubing and fitting are needed to plumb to your sample port? What size fittings do you need? How many feet of tubing? Help your lab. Like I said earlier in the previous slide, if you have percent level VOCs or high level of VOCs expected, please communicate that to the lab on the chain of custody or provide your PID readings. Allow time for the laboratory to prepare and deliver your sampling supplies. Typical lead time on a summa canister order is 1 to 2 weeks. And also, of course, what turnaround time do you need? This is an air chain of custody. Just, want to point out that there are chain of custodies out there specific to air sampling. Very similar to your traditional chain of custody for environmental samples. There are a few additional columns here of information specific to summa sampling that you will need to fill out. All of our summa canisters come with an ALS ID, as well as the flow controller has an ID, so we need those IDs listed on the chain of custody, as well as the starting pressure for the summa canister and the ending pressure for the summa canister. Just want to point out here quickly ALS's TO15 capabilities in all of our laboratories that have the capability to run TO15. We have 4 USA laboratories: Cincinnati, Ohio, Middletown, Pennsylvania, Simi Valley, California, Salt Lake City, Utah, and we also have a couple Canadian labs in Edmonton and Waterloo that provide TO15 testing. Also listed here is our canister inventory. So this gives you a good inventory or a good idea of how many summa canisters ALS has as a laboratory network. And we have the ability, when we're short supplied of one lab, to borrow from another. I do want to point out here that our Simi Valley, California lab is a designated air testing lab. They only do air testing, so they don't test waters and soils. So you can see their can inventory is 4,000, and they're experts with, I believe that they have 30 years of experience in air testing at that laboratory.
Hey Josh, this is Kelly. I have a couple questions coming in. One is from Ronald. He said, will SIM detect naphthalene, which is not a TO15 compound? And also, would I need to make a special request on the COC or have a separate canister?
Naphthalene is on our TO15 list of compounds, even though it is a PNA compound. And you can do it by SIM or by scan mode. Just, we need to know what your reporting level you're trying to reach.
And we have another question from Mary. It said, when canisters are individually certified, are the flow controllers also individually certified, or is this individual certification of flow controllers a separate request?
That's a separate request.
Okay. We have another one from Charlie. He says, is the Waterloo lab the only lab that can do the capability listing there, health-based risk assessment?
I'm not sure about that. I mean, we'll need to ask the Waterloo lab about that and ask our ALS Canada laboratories and get back to him on that.
Okay, I can let Charlie know that information. Also, do you have a preferred pressure range for the stopping of sample collection? This is from Jonathan.
5 inches of mercury is what we'd like to get.
Nicole, you are unmuted if you have something to add.
Yeah, I just wanted to comment. I think with the question regarding Waterloo, any of the laboratories that are listed can do SIM. If they're asking specifically a health-based risk assessment, I was asked about that just this week by a client, and that if you provide the parameters for the laboratory, I think any of us can do that. I think that's kind of a broader term, but any of these laboratories can do ultra low analyses for risk assessments. So that is something that Waterloo can do, but any of us can do it, just depending on what reporting limits and target analyte list they're asking for.
Perfect. Those are all the questions. Josh, you can go ahead and continue.
Okay, thank you. Okay, we were just going to touch briefly here on an alternate air sampling technique. This is passive air sampling. Just to let you know that this is an option, and we do have this air sampling capability within our laboratory network as well. And these are longer duration indoor air sampling, similar to radon, and it evens out variability. With TO15 testing in the canisters, the maximum sampling time that you can do is 24 hours. So if you have a site where it would help you to understand like what's going on over a 2-week span, as opposed to a shorter time frame of 8 or 24 hours, these passive sampling techniques are able to help you achieve that. The passive sampling uses an absorbent media. These are polymers or charcoal-based medias. The contaminants in air absorb onto the media, and then when the laboratory analyzes the samples at the lab, they desorb them chemically or thermally onto the instrumentation. No sampling pumps are used, and the method of collection onto the media is through diffusion. There's a concentration gradient in each one of the types of media, and that is the sampling mechanism. The laboratory reports the concentrations for passive air samples as mass on tube, so you're not really getting a concentration like micrograms per cubic meter or milliliters per minute. It's usually just reported as, for example, TCE per sample, concentration microgram per sample. To report concentrations or sampling rates using passive collection techniques, those have to be estimated and experimentally determined by the lab.
Hi, Josh. This is Nicole. Before we move on, could you go back to that slide? I think there's some more current information that we can share with our colleagues on this. It has been in the past that they did report mass on tube, but it's very common now for the passive samplers to report concentrations. So the concentration is a function of the uptake rate, which has to be provided by the vendor, but almost all vendors now have those uptake rates, which allow laboratories to routinely report concentration. So a very common passive sampler that's on the market is called a Radiello. And the Radiello has a long list of target analytes and uptake rates, which allows the laboratories to report concentration units. Because for many of our clients, mass on tube isn't sufficient for their investigations. They need concentration, and that is possible. So with the Radiello samplers, the SKC Ultra, the TO17, for any of these passive items that we're displaying here, you can get results and routinely do in concentration units. So that's not a problem. It's something that was a little bit in the past, but with the current information from our vendors, we're able to do that. Now, the trade-off with TO17 is sometimes the target analyte lists aren't as comprehensive as they might be in a canister. So there might be an analyte that somebody might be interested in for which the vendor has not determined an uptake rate. In those instances, that is correct, where if the vendor doesn't have an uptake rate, we can either estimate it using a chemically similar compound or report the mass on tube. So it is quite common and routine for us to be able to report concentration units for passive sampling.
Thank you for that, Nicole.
And Josh, I have a few questions coming in as well, and also some comments. If you could just speak a little bit louder and closer to the microphone. Some of our participants are having a hard time hearing you. Another question that I have is, can you provide information on moisture filters for soil gas samples?
At our Cincinnati laboratory, we don't have any experience with ordering those for clients. I don't know if Nicole has anything that she could contribute on that.
No, I think that the flow controllers and critical orifices that we provide at our location and across the network, they do typically have particulate filters, but I'm not aware of there being moisture filters at this time.
And we have one more question from Charlie. He said that you stated that the lead time is 1 week. Sometimes there is a quick request by clients. So what is the quickest turnaround time to provide?
We can provide, cans, routinely provide them with, 1 or 2 days notice, but, we would like to have a week if we can. Now, if that also depends on the size of the order. If you have 5 or 10 cans that you need in a pinch, we can usually provide them in 1 or 2 days. If you need 50, that's not going to be possible. So we can provide them quicker, but it depends on the size of the order. And also, I'll add to that whether or not you want batch certification or individual certification, because the individual certified cans take longer to produce.
And Charlie did specify, he said it's usually 5 or so.
For 5 canisters, most of our laboratories can provide that pretty quickly, but the lead time generally is a function of how many cans you want and whether or not it's batch or individual QC. Most of the laboratories can provide 5 canisters or so on pretty short notice. It also depends on the time of the year, and I think most of the listeners will have experienced situations where they've called the lab and they don't have any. And even with 4,000 canisters at our laboratory, we can still run into a pinch. And that seems to be coincide with very, popular sampling times like winter and summer, when clients are doing their vapor intrusion investigations for, indoor air, and they have to do a summer or winter. And at that point is when every consultant in the country seems to decide to do their sampling at the same time. So labs can get into a pinch. So at those times, you do need a little more lead time, but it is generally a function of how many cans you need and whether or not, as Josh said, they're batch or individually QC'd.
And I have 2 more questions that just came in. I want to make sure that I answer these because I am not sure if we've already done that. Mary asks, helium tracer gas is often recommended for leak checks. Can ALS test for helium with the summa can samples?
Yes, we can. That's an additional charge.
And another one from Lauren. She says, is there an additional cost for ultra low canisters? And what is that charge, please?
Nicole, you want to take that one?
Yeah, I guess everybody's definition of ultra low varies. I'm generally speaking, I think she's referring to SIM. And when we do SIM certification, typically those canisters are individually QC'd. In theory, they could be batch certified, but when people are doing ultra low reporting limits, they want that extra assurance that every detection is going to be verified. So if you want ultra low reporting limits by SIM, typically the laboratories will do individual QC, and there is an additional charge for that. I think I'm going to refrain from quoting that live like this because the price can vary depending on the scope of work and across the laboratories. So if she'd like to follow up with us afterwards, I can give some prices for, the various laboratories that do provide that. But I think I'm going to refrain from quoting it on the fly.
Perfect. I'll make sure Lauren gets your information. Also, Rita wanted to ask a question. I'm going to go ahead and unmute her if she is available. Rita, you are unmuted. Did you have a question?
Oh, no, you've already answered it with the other
Perfect.
questions.
Okay,
Great,
thank you
thank
so
you.
much. All right, Josh, I'll go ahead and turn it back to you.
Yeah, I think we were just wrapping up after Nicole gave her assessment of the passive collections. So we were here at the ending slide, and we were actually on the Q&A session. So if we have more questions, we can take them. Otherwise, that's the end of the presentation, and I'd like to thank everybody for joining.
Wonderful. We'll go ahead and give it a couple more moments for questions. I have not seen anything come up yet. We've pretty much been answering them as they've come in. As we allow people to take their time to ask any additional questions, I want to say thank you to Josh. Also, you heard from Mark Johnson. He is with Josh at the laboratory in Cincinnati, as well as Nicole Bryson. She is a sales manager out in our Simi Valley laboratory out in California. So thank you for everyone being on that call today. We do have some questions coming in really quick. One from Dana. Do you have any tips for sub-slab soil vapor sampling?
That's a really broad
I think that
question.
there are, each site can present its own unique challenges. So, I think we would need to learn more about your site and what you're experiencing. And yeah, I'm sure that we could help you come up with a sampling solution.
I think one thing I would say is have two wrenches. That's a tip. Because oftentimes when we have folks in the field doing their sampling, and if there are failures of canisters, oftentimes it can be because the canisters, the connections might be cross-threaded or they're not tight enough. And one suggestion would be to make sure that you have two wrenches, one to hold the valve stem and one to tighten the nut on it. Because when we do see issues in the field, it can be because they're of incorrect connections. I wish we could provide wrenches with every order, but unfortunately we're in the lab business and not the wrench business. But I would suggest something to simplify that is to have two wrenches in the field. And if there's something more specific they would like to know about, I'm sure any of us could assist with a more specific question.
I'll just add, this isn't really specific only to soil gas or subslab sampling, but for any vapor intrusion sampling you're doing where you're ordering summa canisters and flow controllers, I think it's always a good idea to have order an extra can and flow controller to have on hand in case you have problems in the field and you have a leak and one of your cans is ruined. Have a backup on hand, and we're not going to charge you at the laboratory if you send back one unused can. Now if you order one can from us and then you return it unused, then yes, you probably will be charged the rental fee on that equipment. But if you're just ordering an extra can to have in case something happens and you send it back with other samples that we're analyzing, we're not going to charge you for that.
We have another question from Ronald. He says, are there any other diesel compounds besides naphthalene that can be detected?
I'll take a whack at that one. The semi-volatile, well, I guess if you're just talking in general, the laboratories can do like a total petroleum hydrocarbon as diesel analysis. When you start getting into the semi-volatile range, canisters and Tedlar bags aren't a suitable sampling media for that. So once you start getting into the higher boiling point and molecular weight compounds, you need to start looking at sorbent tube sampling approaches. So for indoor air, ambient air, a sorbent tube like TO17 or charcoal tube that might be offered by some of the other labs can be used. And then in soil gas, it can be tricky to look for that since, again, higher boiling points, they may not exactly be volatile in the vapor phase, but we do occasionally get inquiries for that. And again, with those heavier compounds, you need to start considering sorbent tubes. So, ALS does offer analytical methods and approaches for diesel range. I know that Simi Valley does, and I would think that Cincinnati probably does also, at least from like a charcoal tube or sorbent tube method that's more of like a NIOSH or OSHA method.
Okay, and it looks like someone just wanted to make a comment in regards to helium tracer analysis. It says even if the lab can check for tracer gas, it's still a good idea to conduct the leak testing in the field. Field testing will reduce the possibility of poor quality data or the need to return to a site later and resample.
I think we agree with that practice, and I think across our clients, we see a range of practices in the field. There are definitely some clients that will bring the helium detector into the field and make adjustments of their sampling trains on the fly. We also have some clients that don't do the adjustments on the fly, but they do use helium as a tracer. And it's really just a trade-off for our different clients based on what their field staff might be comfortable with or what their sampling protocols require. So some will do the adjustments on the fly. Some will use helium and just, send it into the laboratory to see if there's a helium hit and go back. We still have lots of clients that use other tracers like isopropyl alcohol in the field. So depending on the state and the regulations, we do still see a range of practices when it comes to tracers for leak checks.
Awesome. Thank you, Nicole. That is the last of our questions that I've seen come in. If anyone still on the phone call does have any additional questions, feel free to use these email addresses here, and you can reach out to Josh, Mark, or Nicole for any follow-up questions you may have. Thank you to everyone for attending this webinar Wednesday series. This has been recorded, and we will post this on our YouTube channel. You just have to go to Search ALS Limited to find our channel and then click on the North America playlist. There you will find a wide range of video resources and past Webinar Wednesday presentations. Also, please follow our showcase page on LinkedIn as well as other various forms of social media. We always post links to our future webinars and other valuable resources there. Thank you to everyone for attending, and go ahead and enjoy the rest of your week. Thanks, everyone.